And for the last conic section, we're going to look at how to graph and write the equation for a hyperbola. Our definition for a hyperbola is actually very similar to the one we had for an ellipse. We still have the set of all points whose distances from two fixed points, the foci, have a constant. Now it used to be a sum, this time it's a difference. So we're saying if we pick a dot on the graph and we take the distance to each of the foci to it, each focus compared to that length, if we subtract them, we'll always get the same answer instead of adding those distances together. So we still have an A, a B, and a C value. A lot of the rules are very similar, but slightly different names. A is sometimes called the vertices, but in this case, it's going to be more frequently called the transverse axis endpoints. What we're going to focus on is that we're going to kind of lightly sketch a box, which helps dictate the shape of the hyperbola itself. So basically, A will be the distance from the center to the edge of the box where it just touches the hyperbola shape. B is going to be the perpendicular distance. So these could flip whether they're going up and down or left and right. So B will be the distance towards the edge of the box that does not touch the edge of the hyperbola. C is still the distance from the center to the focus. The big difference on the hyperbola compared to an ellipse. For an ellipse, the endpoints, the vertices, were on the outsides and the foci were on the inside. This time we've flipped them. This time the focus is farther away than the points on the A distance. And just like with the ellipse, A and C will go in the same direction. So if A is going left and right, then C will also go left and right, and vice versa. If A is going up and down, then C will be going up and down as well. Now do note that the formula looks the same for finding C, but on the last shape, the ellipse, it was the square root of A squared minus B squared. So now the sign has flipped. So it is slightly different. Do be careful about that. Make sure you emphasize that in your notes. They are different formulas for finding C, whether it's an ellipse or a hyperbola. So here are the formulas. The formulas also look very similar to an ellipse. Again, the difference being that there is a small sign change. It has become a minus in between the two fractions instead of a plus. So for the hyperbola, the standard, rather than always having the x variable come first, you'll see that that sometimes flips. What's important for a hyperbola is that you always have A come first. So B will always be the second denominator. And we do not have the rule that we had last time where A is always bigger than B. That's true for an ellipse, but it is not true for a hyperbola. So you have to be a little bit more careful about the order you write the fractions and where you put the A, B, and C values in this case. HK is still the coordinate for the center. As I said, A squared will always be your first denominator, not necessarily the bigger one. And then again, this is reiterating the formula for finding C. So usually if they give you the foci, that means that you're going to need to find that length of C by measuring the distance to the center. And then they'll give you one of the other values, A or B. So you usually only need to use this formula when they give you the distance or the coordinates of a focus. Now the last image did not show the axis labels, so here you can see the transverse axis is the one that does touch the edges of the hyperbola, and the conjugate axis is the one that goes to the perpendicular sides. This shape could be flipped sideways though, in which case the transverse axis would go up and down and the conjugate axis would go left and right. So it's that the transverse axis touches the edges of the hyperbola, not that it always goes horizontally. You'll also see that part of the reason why we draw the box using the A and the B values is because then we can construct asymptotes that go diagonally through the corners of that box, and then that helps us determine how wide to make the hyperbola on the two sides. As with the last shapes, I've tried to give you some rules based on what information you were given at the start of the problem. So if they give you a pair of points, same idea, we're going to find the center first by using the midpoint formula, or if you sketch the graph, it's usually pretty easy to find the coordinate for the h and the k value. Also, if they give you a pair of points, make sure you measure the distance from that center after you find it. And then if it's a transverse axis endpoint they gave you, then that will be the length of A going from the center to the point. If it's the conjugate axis endpoint, then that will be the distance B. And if it's a focus that they gave you for the coordinates, then the distance from the center to that point will be C. As far as determining which number is A and which number is B, pay attention to what's changing in the coordinates they gave you. If they gave you the transverse axis endpoints, if it's the x coordinate changing, then that A value goes underneath x in the formula. If it's the y coordinate changing, then that A number needs to go underneath y instead. This next rule is also a repeat. If they give you an axis length, make sure you remember to divide it by 2 to get A or B, because the axis lengths are 2A or 2B. And then the newest thing we have to deal with is that they might give you the slope of the asymptote. So what will be tricky on this is knowing whether the numbers they gave you are A over B or b over a. You can always determine that by using the rule slope is rise over run. So basically, if you have the formula, make sure you're always doing the number underneath y in the numerator, which could flip, could be a or b. And then in the denominator, you'll have the number underneath x, which should be the other number, a or b accordingly. So whether it's a plus or minus a over b rule or b over a, just focus on what's under y over what's under x. So now we'll look at an example. You can see that we were given the transverse axis endpoints of 0, 3, and 0, negative 3. And then the conjugate axis has to go in the perpendicular direction. So since the transverse axis endpoints were going up and down, I know that the conjugate axis has to be going left and right in this case. But don't forget to divide this number by 2. So I'm actually only going to go half that amount left and right from the center. So this makes the edges of our box. Once you have all 4 sides shown, you kind of want to just lightly sketch in the dimensions of the box, even though this isn't the hyperbola itself. It helps us guide the shape of the hyperbola. And then once you have the box drawn in, you want to draw in some more lightly sketched lines for the asymptotes that go through the corners of this box we drew. So none of this is the hyperbola itself. This is all just to help figure out the shape of the hyperbola. So then your last step in these cases, the transverse axis endpoints are the ones where the hyperbola actually touches the sides of the box. So now I know that it's the parabola on the top and the bottom. So it's kind of a parabola shape, and it always touches the transverse axis endpoints, not the conjugate axis endpoints. So based on the sketch of the hyperbola, now I can see that the location of the center, the h and the k value, that one's 0, 0. It's the midpoint of the sides of the boxes that I've drawn in. A is the distance from the center to the hyperbola shape, the transverse axis endpoints. So it was going a length of 3 in those directions. And then perpendicular to that, the sides of the box were a length of 2 away. So A is 3, B is 2, based on how far we're going towards the hyperbola and perpendicular to the hyperbola for the box we drew. So now we can write the equation pretty easily. Remember that for the hyperbola, A always is the first denominator, so A squared technically. So this time my first denominator is going to be a 9, and my second denominator is going to be B squared always. It's always an equation set equal to 1. This will never change. And then the most important thing is to make sure we know whether the x goes on the first numerator or the y. Since this hyperbola was going in the y directions, it was on the top and the bottom of the box that we drew, the y is the value first, and then x is our second numerator in this case, the side that does not have the hyperbola shape on it. I didn't have to do the y minus k and the x minus h part because those numbers were 0, so we didn't need to write that part in. Okay, new shape, same idea. I'm going to start off by plotting the coordinates they've given me. So we have transverse axis endpoints at -3, -4, and then another one at -3, +2. This time we were given the foci, so we don't know the conjugate axis length yet. We'll have to find that. So I have -3, -6, and -3, 4. Remember, for this shape, the foci are on the outside of the vertices. So we do need to identify the length of the distance from the center, so we can find the center is here in the middle of those. So from the center to the transverse axis endpoint, that will be our length of A, which in this case is 3. And the distance from the center to one of the focus endpoints, doesn't matter which one you pick, that distance is 5. So if they give you the focus endpoints, this is the case when you have to use that formula with the a squared, b squared, and c squared in it. Now remember that the sign does flip for the a squared, b squared, c squared formula, whether you're dealing with an ellipse or a hyperbola, so always double check that. In this case, we have a squared is 9 and c squared is 25. So when you subtract the 9 and take the square root, we get a length of 4. So that's the distance we're going from the center in the perpendicular direction, so the opposite direction from the transverse axis endpoints. So now we have enough information to draw in the sketch of the box here. Remember, we're using the points on the inside because it's the focus that's on the outside of the box this time. And then we can use the corners to determine where the asymptotes will go. For the hyperbola itself, remember that the parabola shapes are going to touch the ends that have the transverse axis endpoints. So since those were the dots on the top and the bottom, that means that the hyperbola shape is also on the top and bottom of the box that we drew. It should also go towards the focus endpoint. So if you have those drawn in, then you can use those for reference as well. So here we have our hyperbola shape, which we can now use to write the equation. So I always like to start off with the basic kind of outline of what the standard equation looks like. So it's always two fractions being subtracted, set equal to 1. Now, remember that the first denominator always needs to be the a squared value. So in this case, if a is 3, 9 goes first, and then b we found was 4, so b squared was 16. For this shape, a is not always bigger than b. Don't forget that. For figuring out whether it's x or y that goes in the first fraction, that again comes from the fact that if the hyperbola is opening in the y directions, then we put y first. If it's opening in the x directions, then we would put x first. So this one, it's going to be y minus, and then I didn't label this coordinate. That center was at -3, -1. So the y coordinate was -1. So the double negative cancels on subtracting k. And then we have x minus the x coordinate of the center. So x minus -3, the double negative cancels and makes that a +3. So there's our standard form for the hyperbola. And one last example, we again have the transverse axis endpoints. So I have -1, +5, and then +5, +5. So as soon as you get a pair of points, you should be able to identify the coordinate of the center halfway between them. So now I know that my h and k values are going to be 2, 5. And since I can now determine the distance from the center to either of those transverse axis endpoints, that means that now I know a is equal to 3. So the hardest thing about the questions where they give you the slope of the asymptote is we have to be careful about whether we use a over b or b over a. Now in this case, the transverse axis endpoints were going in the x directions. So that means it's going to be a formula where x comes first. So if I'm thinking about rise over run, then rise is going to be the number under y on top of the number under x. So I know it's going to be the b over a setup in this case, because I've identified that it's the equation where x is going to come first, since it was the x coordinates changing in the transverse axis endpoints. So once you identify whether it's b over a or a over b, pick whichever fraction you need, and then set it equal to the slope that they gave you in the question. Now, I already knew that a was 3, so I replaced the a with 3, which means I can now solve this equation. In this case, you can probably just see that b is equal to 4. For the denominators to stay the same, the numerators have to be the same. If the numbers were not all matching, you could always just cross multiply and then basically solve that equation for whatever you're missing. So in this case, we can multiply both sides by 3 to solve the equation, and we should get that b is equal to 4, which means I know to go up and down 4, so I go a little bit off my grid on this shape that I have, and down 4 for the other side, which now gives me the dimensions of the box for my asymptotes here. So the corner to corner, that gives me the asymptotes to help guide the shape of the hyperbola. And when they told us that it was 4/3, basically if I do the rise over run of those diagonal lines, I should get positive 4/3 and negative 4/3 for the one going diagonally down and right. So in this question, we mentioned that the transverse axis endpoints had changing x coordinates, which means that my hyperbola shapes are going to be on the x sides of the box. And now we can write the equation out. So the first denominator is always a squared, so that's going to be 9. The second denominator is always going to be b squared, so that will be 16 in this case. Since this hyperbola is going in the x directions, we want to put the x minus h first. So x minus 2 squared and then that means y goes in the other fraction, so y minus k squared. And that's it for sketching and writing the equation of hyperbolas.